One from January 94 up to December 96. The other one is 97 up to 99. Two sample, 3-year period, two sample. So we like to run the solver function to estimate the style for each sample period. Notice there is no overlap in the input data. In my paper, I used overlap data because of limitation of sample. Yeah, let me get to that. So let me finish this one first. Okay. So in terms of input data, this is the model right there. This is the Sharpe's style analysis model. We assume, this model assumes, mutual fund return is a combination of some kind of factors or asset classes available to this guy, okay, available to mutual fund, plus some error term, sampling error or some measurement error, whatever error. Right? So we have to, this is the data. See? This is how I got all these factors. In this particular example, I'm using 9 factors, 9 asset classes. Assumption is that this guy, the mutual fund guys, are exposed to these 9 asset classes. So this is the world of investment opportunity for this guy. Okay, so let me see. F1 is S&P, BARA. So this is a kind of large cap index for growth. Large cap value asset, different type of asset classes. Mid cap, small cap, that's all stock, right? Opportunity. Then I have bond, corporate bond index. This is possibility. Right? If you invest something into here, you will earn this much for every month. Government bond and T-bill, so 9 of them. We are assuming that these 9 asset classes are the investment world faced by this guy, Magellan guy, Fidelity Magellan Mutual Fund Managers. We are evaluating style for Fidelity Magellan. Okay? So that's R. This is the, I'm using monthly return, January, February. So we got that, R, right here, right? And all these F's, 9 of them. For first sample, okay? First step is to compute the residual, EI, which is the difference between mutual fund return and portfolio of these asset classes. That should be E. You compute that for every month. Okay. You got the number for F's. We got the number for R. So in order to compute EI, you gotta assume some number for factor loadings, B1 through or investment weight. As before, we've done, we assume arbitrary number. There are 9 of them, so about 10, so 10%. Sum it up, 90%. That's arbitrary at this point, any arbitrary number. So that we can compute this. Little bit involved, I know it's that, but if you go through this, in order to compete as a good manager, nothing comes in easy. You gotta make an effort to be excellent. You go through this. So each month, I computed E, residual, according to the model. So K13 with R, minus this portfolio of asset classes, I'm using some product to get that portfolio return, portfolio of asset classes, assuming these weights at this point, arbitrarily at this point. Right? So you compute all this residual, which is that for every month. We're talking about 3 months, 3 years, so 36 observations, more than 30 observations. Like this. Compute that. The same thing for second sample period. 97 to 99. So far so good, right? Did I lose you already? So you have followed me. I see some eyes. I'm lost. One more. I'm done. I'm lost. Then, so far so good, hopefully. Then compute this for each. What is it? Variance of this residual error term using VAR, right? This is the volatility, how this error moves for this particular sample period. I think we are ready to set up the solver function now. Okay. Again, the model is this. We're going to ask solver to minimize what? Minimize this error, volatility error, minimize it by changing the weights. Very similar to ordinary portfolio model, right? Under some constraint. Constraint 1 says sum of B's portfolio weight should be equal to 1, and also all B's should be greater than 0 and less than 1. Okay, so that's the way. And I'm done. Okay. To install this solver, do this every day. No, that's how these people set it up. Okay. Then it should be under where? Do you remember? Oh wow! How much you know? You didn't know before, right? So under data solver, let's solve this. What is the beta that minimizes the volatility of the error? Or the same thing, I can say it this way. What is the beta? What is the allocation? Right? So that the portfolio of your this asset classes generated by this model, right, mimics actual mutual fund return. How close we can, that's the idea. If you're closer to this actual mutual fund return, the error term will be minimized. Right? So we are using the first approach. We like to pick this beta so that error term, the volatility error term, would be minimized. Okay? So I think I told you everything we need to know to set this thing up. So objective function should be M. Is it 6?
Yeah.
Trust you. Well, click on here. Oh, M6. Min. By changing all these weights, 9 over B6 through J6. Try different combination. Does it give you minimum value of this? If not, keep doing. so hard. Okay. Realize it. Constraints. Hmm? Add, yeah, okay, I see. Add. Hmm? K6
equals
equal
1.
1. Add one more. B6?
B6.
Oh, I see. B6 through
BJ.
B6. That's right. Greater than equal to 0 and less than equal to 1. It turns out this less than 1 is redundant. Once you got that sum should be equal to 1 constraint, then it should be, the third constraint should be met with the second constraint greater than 0. There's no way you can get a less than, greater than 1 when there's first two conditions on it. Right? But either way, that's okay. If you feel uncomfortable with it, just put extra constraint saying that add one more, right? That should be less than 1. So if you look it up, see, sum should be equal to 1. All b's